Hello and welcome to the Fat-Tailed Thoughts podcast. My name's Stephen Dickens and I'm your co-host, and I'm joined as ever by my dear friend Jared Clee. Welcome to the show, Jared.
Good morning, Stephen. How are you?
Yeah, not too bad, not too bad. Bit of trepidation for this subject for this week. I don't know about the dark recesses of your brain, buddy, but why you decided to write a newsletter and start a two-part series on paper in banking. I'm going to play the voice of the skeptical audience here.
Well, I figured in kind of post-Thanksgiving, maybe people are a little worried about what they're getting people for the holidays. Maybe they need some good material, put them to sleep at night.
You couldn't have written about inflation
for the month here.
You couldn't have written about inflation. You couldn't have written about the jobs report. You couldn't have written about the M2 money supply. I mean, you couldn't have written about all these things. But all joking aside, listeners, go recommend you read the newsletter. Interesting subject, despite me busting on Jared here. So let's get into this. Paper in banking. Not gonna be clickbait on our LinkedIn and Twitter profiles to get people, but I think worthy of some discussion. So just frame us up here, get us going. What are we talking about and why?
I hope so, because this is a problem, Stephen, that I've lived through. So if we go back to past life, I did stuff in the artificial intelligence world, specifically working around regulations. And I'll tell you again, I called this fintech's dirty secret. I'll tell you one of the other dirty secrets in the banking world. Regulators are not in the US, are generally speaking, not required to publish regulations digitally. They're only legally required to publish them on paper. So you actually have a couple of states that refuse to publish them publicly digitally. So the folks like Thomson Reuters and whatnot that offer your regulations platform and your Cornell law platform, the like, that's the only place you can get digital access. Otherwise, you're going into the courthouse or the state house or whatnot and go and grabbing the paper yourself. So you can imagine being a bank that has to operate in that state. You're paying the troll toll every time just to find out what it is you have to do. And deep in the bowels of this, Stephen, are exactly the types of companies that we're talking about here in the processes we are here. So this stuff's very, very real.
So let's sort of frame up where this is a first of a two-part series. Trepidation from my voice, trepidation from the listeners. We're going to be talking about paper and optical character recognition for 2 episodes, so bear with us. We'll try and make this fun, listener. Don't worry. But just get us framed up. Yeah. What are we going to talk about in the show today? What's the scope of the first show? And then give us headlights into where we're going to go next.
So we're starting with the raw mechanics of this. So if we think about bank statements, so let's talk about individuals and financial statements for a moment. If we talk about bank statements or credit card statements or your tax forms or your I-9, your W-2, et cetera, that's all physical pieces of paper. And even if we convert that to PDF, as we'll find out in a sec, that's still not a format computers can understand, so to speak. So this week, we're diving into the mechanics of how do we go from this analog form of data into a digital form of data that a machine can actually understand and start doing analytics against. Next week, we'll talk about the opportunities that come with digitizing that data. There are a bunch of startups that for the last however many years have been building better and better machines to digitize it. Now, you can imagine, Stephen, if I've got access to your bank statements, your credit card, your tax forms, I've got a pretty good picture of who you are, and I can start to build really interesting stuff on top of that. Basically, I've got a data platform where I can now build new offerings, et cetera. So next week, we're going to dive into both what those opportunities are, kind of what the future of this is, as well as a lot of the really interesting startups that are already starting to chomp at the bit and provide some of these offerings on top of just that digitized data.
So I hadn't put any mental effort into understanding the scale and scope of this problem until I read the newsletter, and you made me pause and think, which is, for the listeners, why I do this show with Jared, so that I get smarter, by the way. And I hope you're on the same journey. Sort of smarter by association is what I'm going for with this podcast series. Talk us through the size and scale of this. What You mentioned some of the bank statements, the W-2s, the I-9s, the sheer, and I suppose I see that, and I applied for a green card over the last few years. At one point, I took a picture of the paperwork that was on my desk that needed to go through, and it's about 2.5, almost 3 inches worth of paperwork. I've got 4 children, so that didn't help because every form, then there were 6 of us. So I kind of get, I kind of get the size and scale, and I think probably our listeners do. But just get us orientated, just sort of double click there, if you will.
Let me give you 2 examples from work I did previously. I worked with a major bank that what we'll just call a major Wall Street bank that's kind of full service banking. We were talking about kind of big pie in the sky, blue sky thinking things we could do. And the gentleman across the table looks me dead in the eyes. He goes, "How do we use less paper?" It's like, "What do you mean, how do you use less paper?" He goes, "Jared, we spend $20 million a year on toner. Never mind the cost of paper, never mind the cost of the people and processes, never mind the cost of anything else in that process. The cost of printing out that paper, ink, toner, was $20 million a year for the bank." It's wild numbers. So that's one case. Another case, I was working with a major bank in the trade finance space. So trade finance being if you're shipping cars, whatever, in shipping containers across the world, you don't know as the seller that you're going to get paid. So typically the buyer will engage a third-party bank who will issue a letter of credit that basically guarantees the seller they'll get paid. There's a bunch of other paperwork, bill of lading and whatnot that demonstrates what's getting shipped, etc. That's really important financial services. One, you want to know what you're writing the credit against, but 2, you want to make sure that people aren't shipping bombs across the ocean and whatnot. So I was working with one of the major trade finance banks. They have a very robust system that reviews the documents, pulls out the words, analyzes it, runs it against terrorist watch lists, like make sure the guy shipping it isn't a terrorist type thing. They got round about 10,000 hits a month. So meaning the machine was reviewing the paper, it pulled out 10,000 words, names, etc. that needed quote unquote additional manual review because there was a possibility that it was a terrorist or on a sanctions list or what have you. Stephen, 3 were actual hits. 3 out of 10,000. And that means the 9,997 have to be manually reviewed and go, nope, nope, nope. I mean, this is rooms full of people that go and do this day in and day out. It's wild.
So this is cost, time, people, resources. It's a significant drag. And when we hear about digital transformation and we hear about digitizing and new banks, neobanks, fintech startups, is this and I don't want to describe it as technical debt because it's probably more operational debt. Is this the operational debt that these big banks are dealing with?
I wouldn't call it debt, and Stephen, I promise I will answer that question before we're done. Okay. In fact, there are good reasons for having people deeply involved in these processes. So I'm going to hesitate to call it debt. Admittedly, these systems can get better, but we will come back to that.
Okay. So talk us through, get us started here then, sort of paint the picture of where you've given some highlights into the size and scope, sort of paint the picture and take us through sort of the journey that the newsletter goes through and kind of where we're going to take the listeners here.
The challenge, Stephen, with paper is that it's paper. And to be clear for the listeners, a PDF, those things you open up in Preview or Adobe or what have you, are no better than paper. And what I mean by that is if you and I write a document, a digital document in Microsoft Word, even though you and I are looking at words on the page and bullet points and whatever, when we save that document as a .doc or .docx, it comes with a whole bunch of digital data in the background that tells the machine this is an A, this is a B, this is a bullet, etc. So the machine, the computer, actually knows how to read that data, not based on the shapes of the characters on the page, but based on the digital data that's stored in the background that informs it. a piece of paper, if I take a picture of it, or a PDF, does not come with that digital instruction manual that tells the machine how to read it. So instead, what we're stuck doing is taking a picture of it, which a PDF really is effectively a picture, no different than what you'd have out of your camera. And the machine has to go and decipher the ink blots on the page and say, I think that's a capital T, then a lowercase h, then an E. Okay, that's a word. How do I know it's a word? Because there's a space before it and after it. Okay. So it's effectively guessing as it sees the shape of the pixels and then the amount of space between the ink blots on the page to say, okay, word, 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 paragraph, paragraph, paragraph.
And just to unpack an acronym that's OCR, Optical Character Recognition, technology that's been around 20 plus years, I would say.
It's been around a long time. It keeps getting better, and it's gotten better on two different parts. One is, frankly, the cameras have actually gotten better. Critically, it's less about the glass and the lenses there. It's more about our ability to capture and store digital data at high volumes. Storage has gotten cheaper and cheaper. The ability to differentiate basically the fine grainedness of the view has gotten better. So that allows us to especially for things like handwriting, where doesn't quite look like a letter anymore. That's quite helpful.
You're talking about my handwriting, is that what you're saying?
Well, you and me both. I should have been a doctor.
Yeah, I should have been writing prescription notes, I think.
And secondly, what's gotten better is, as we'll get into, the AI systems. So it's not just strictly rules-based. The machines are starting to get better and better and better at saying, okay, that kind of sort of looks like a T, even though it was scanned in blurry and upside down or whatever.
Well, that was one of the interesting things that I learned from reading the newsletter, that when we fill these captures in, that we're actually training the machines. So go read the newsletter. You'll have the same double check that I did. Talk us through what these capture providers, when we authenticate to these systems, what's going on there? Are we training the machines? Because that's how I took it.
Yes. So this is it's a brilliant play by Google or Alphabet or whatever we're calling them today. So they a couple of years ago digitized about 25 million books. That an enormous volume of paper. And as you can imagine, especially as we talk about older books where the pages are starting to fall apart, or we talk about just simply imaging that many books, you inevitably get like words along the spine of the book that are, when you take the picture, they roll over the spine. So they're kind of squished up in there. You'll get a page that's blurry because somebody moved it accidentally, or the page is crooked or what have you. So as a result, you get most of the words you scan from the books are going to look like what you've trained the machine to see before. And what I mean by that is the machine is quite literally in its memory going to have, I've got this pixel pattern of a horizontal line on top of a vertical line. That's probably a T. But we can have slight variations around that as we talk about font type or this blurriness or what have you. So Google's basic idea was, hey, look, we've scanned more of this stuff than anybody else, which means we've probably got the best general purpose OCR technology in the world. So if we can't understand what this word is, nobody probably can. So that turns out to be a good test, because it means we don't think anybody has a robot that could actually understand this if we can. So what they do instead is they go, well, we'd also really like to understand this. So CAPTCHA is when it gives you that jumble of words or a set of pictures and says, are you a robot, when you're trying to get into a website? On one side, what's happening is Google saying, if we can't understand what this is with the machine, nobody can. Therefore, it's going to block robots. But two, every time you and I say it's QNPR37 or whatever it is, or here's the 7 pictures of a bicycle, what we're doing is we're informing Google's OCR machine that says, hey, this thing you couldn't understand, these are pictures of bicycles. That is training data for the AI, so that it understands the next time it sees something similar, goes, hey, I've been told what that is before, and it's effectively getting smarter.
And to also relate this to autonomous vehicles, if you'll just bear with me, when I'm asked to identify what are traffic lights and what are bicycles and what are mopeds, I'm training the machines to be able to spot those in busy street pictures and help train the machines, which was a reference. I kind of thought that was going on somewhere. I didn't realize we were the monkeys tapping the keyboard. So, I mean, you learn something new every day, I suppose.
It's very cool, and I want to highlight that, because as we talk about, I mean, let's put Google on a pedestal there in terms of what they can do with data and whatnot. They are employing millions and millions of people, Stephen, namely you and me, to go and train their machines. I mean, that's what it takes to get these things better. It's a huge manual effort any way you look at it.
Yeah, I'm doing 1 or 2 of those a day. Times that by the amount of people who are doing the same. You've got a good pool of trained monkeys, I suppose.
That's exactly right.
Okay, so talk to us a little bit about OCR. You debunk some of the numbers and unpack what's going on there. Unpack that term a little and go through that. I think that's interesting. Some of the sort of accuracy rates you talk about in the newsletter. So talk us through that piece.
So let's talk a little bit about the different types of documents that come in and how that informs those accuracy rates. So at kind of your most basic document for a machine is a form. Forms are notoriously, if we think about tax forms, for instance, humans are notoriously bad at forms. Reason being is the form has strict instructions that says fill in stuff here, 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 and here. We humans, unless we've seen that form before, we're pretty bad at following instructions. And I used a hilarious example from World War II in the letter where
that app. But seriously, if there's one thing you should go look at in the newsletter, it's this surrender document and how people didn't know where to sign. I mean, just expand on that for the listeners, Jared, because it cracked me up literally on the train last night.
And this is going to live on forever. At the end of World War II, we have a document being signed, the armistice being signed in Japan. And each one of the countries has its representative sign at the end of the document. And you've got the classic signature line with the title of the representative underneath it. And to throw them under the bus here, Canada's representative accidentally signed instead on top of the line, signed on the next line below. Well, Stephen, the document was already printed. This is pre-computer era. This is typewriter. They didn't want to redo the whole document. So each subsequent signature line, like 5 or 6 of them, the representative has to go and cross out the name of the representative that's there, rewrite in their representative name, go and initial the change, and then sign it. And then the next person and the next person and the next person. And the last person just gets pushed off the edge of the page and is kind of scribbling in, just trying to fit on the edge of the page. And you're thinking that this is as formal a document as we'll ever have. This is going to live on forever. And yet humans can't understand forms, the very basics. It turns out it's a hilarious example, but it turns out they're actually really good for machines. Reason being is those forms come with 2 really big advantages for a machine. One, they're the same every time. So once you know how to read the form, you know that this box is first name and that box is last name and that box is social security number or whatever. 2, each one of those boxes comes with what we call metadata. Metadata is quite literally data that describes data. So when you want the machine to go and read that form, you don't just store Jared and whatever else comes after it. You store Jared with the metadata first name, Clee with the metadata last name. So you know what those individual entries are. So forms, those big advantages, you know where on the page the data will be, and you know what to expect in each one of those locations. That makes it much easier for machines to understand.
So we've designed those forms, I'm imagining now, for the OCR technology that goes behind it so that it's easy for that machine to read that form and then turn it to be digital? Or am I being a cynic?
You're being a cynic. Absolutely not.
Okay.
Absolutely not. So instead, what we have is we force the OCR companies to go and build tooling, and it really looks like drag and drop squares, where for most of their systems, if they get a new form they've never seen before, you can drag and drop a square and say this box, and you'll get a pop-up when you do so, and say, what is this box asking for? Well, it's asking for address. Is address in one line or two lines? Like, is it or do we have a different thing for city? It's okay. It's two lines. This is just asking for street name. Got it. Okay. Then when it pulls in that form again, it will say, okay, I know what that box is looking for. We increasingly have AI assisted versions of that, where it will take that in and say, hey, I see this box is labeled last name. Do you want this to be last name? Now, where those get a little funky, Stephen, is inevitable. If you have a long last name, or you've got those stupid ones where it's like, write your social security number and here's a teeny little box for each one of the letters to fit in. In those scenarios, if you say write the letters or the numbers and they go outside the boxes or they extend beyond it, now you start to cause problems for the machine. They are getting better at anticipating that, but that again is degrees of hopefulness.
My wife's signature and trying to get it to fit in the box is a perennial problem. It's like, make it smaller, honey. Make it smaller. We need them to accept this form. So you talked about accuracy rates, and I think there was some interesting information in there. We've talked about some of the challenges of form design, people putting data into that form. Talk us through some of the accuracy and error rates that we're seeing.
Let me hit on unstructured first, because I want to talk about accuracy and precision. I really only talk about accuracy in the document, but precision is a really important concept. The other kind of major type of document here, Stephen, is unstructured. So think about a regulation, or think about a book or the like. Think about a textbook is a good example here, where you're going to have like a header on the page that's going to say which chapter it is and a page number. And then you're going to have a big bold thing that's the title. And then you're going to have subheaders that are slightly smaller and slightly less bold. And then you have paragraphs and bullet points and block quotes and all these kind of structure. We humans are really good at looking at that and going, okay, header, footer, don't care. I need to look at the body of the page. When I see bullet points, I know it's following the paragraph that came before it. We're good at those visual cues. Because a machine does not know what to expect when it sees that, that is a really hard problem for machines to deal with. It can't anticipate. So not only do you have to have rules in there that say, okay, things that are bunched together are paragraphs, bullet points go with the paragraph before it. When you then go from, say, one textbook to the next, and the first textbook has spaces in between the paragraph and the bullet points, and the next one doesn't, well, that's a new pattern the machine has to learn. It becomes very difficult to anticipate. That problem gets even harder when you talk about understanding the content in that document. Because again, on the form, it's like, hey, first name, last name, address. Whereas if I'm just giving you blocks of text, you as the machine don't know what's going to be on that page. So there's an inference that has to happen that, again, is a much harder problem to solve. So I go down that rabbit hole, Stephen, because it gets us into the challenge of accuracy and precision. Mm-hmm. So in normal human life, we kind of think of like 99% accurate or 99.9% accurate. You know, well, that's basically 100%. Well, the challenge here, Stephen, is that when we start talking about the scale of data that we're dealing with, it turns out that those numbers are wildly inaccurate. So oftentimes you'll hear for if you engage with an OCR company, you'll see we do with the machine, we can get at 99.5 or 99.9% accuracy. And with additional manual reviews, we can get you 5 nines accuracy, 99.999% accurate. Well, that's on average a mistake every 10,000, one in every 10,000. Well, 10,000 characters is about 3.5 pages. You can imagine if you were reading a book and there was a typo every 3.5 pages. That becomes a really big issue when we start talking about things like regulations and law, where a mistake every
Where a comma
300.
can make the difference between how something's interpreted.
Exactly. That's exactly why we end up with this massive manual effort. One, we talked about before, marking up all those forms, but two, we simply don't have machines that get us to levels of accuracy that are anywhere near adequate for much of what we deal with in financial services, medical places where we basically need to guarantee a damn near 100% every time.
Hmm. And is that getting better? Are we seeing that go 5 nines, 6 nines, 7 nines? Are we on that exponential sort of improvement curve?
So we have two fundamental different challenges there, Stephen. So one, and I'm gonna tack on a third at the end, which is the 100% accuracy set of challenges.
Hmm.
So in general purpose, so like the stuff Google is doing, trying to digitize books. Yes, we are getting increasingly better accuracy with the machines. And a lot of that comes from the amount of data that's been chunked through. A lot of that comes with, remember, you and I are doing a heck of a lot of work training that machine.
And is that just improvement in AI, inferencing,
And
process?
massive data sets.
Yeah,
Massive.
massive data sets, improvements in the computers and the processing technology to push that through at speed.
Bingo.
Yeah,
But it can't,
okay.
the data sets and the amount of training data cannot be overstated here. It plays a massive role. Where we don't see as rapid an uptake, although we see much better techniques today than we used to, is in narrow domain problems. So let me explain. If you have an OCR company that's digitizing the I-9, the I-9 is the I-9 is the I-9, they're going to see a bunch of those. They know what to anticipate. But if you go into Chase and then you go into Bank of America and you apply for a mortgage, you're going to see two different mortgage forms at each one of those banks.
Hmm.
The challenge for the OCR company is they're not going to have a lot of samples of those filled out forms.
Hmm.
So as a result, you have much more sparse data to look at. So even though the machine can get better, you've got a data problem. You're just not going to have enough samples in order to train the machine. In which case, while we can get incrementally better with new techniques and the like to improve the AI engine, we're always going to be hobbled by lack of data, which means people. It always comes back to people.
So one question that's in my mind: why do we just not get rid of it and turn it into a digital form on a website somewhere? Or am I being too simplistic?
It's so we're
So
starting to.
let's take mortgage applications because you went there. I bet you there is a firm I can go and enter all that in online and not have to enter it in as a paper form. Why are the banks not just bulk moving to that methodology?
So we'll hit on them more next week. Blend is the kind of the big startup in this space today. They've done wonderful work digitizing the mortgage process and the mortgage forms. The challenge, Stephen, is not the form. The challenge is the bank process that goes around the form. So
Mhm.
if we think about how a mortgage works in a bank, you and I, if we're applying for each applying for a mortgage, we go and submit that 3.5 inch stack of papers. That doesn't just get consumed by one department in the bank. That needs to go to underwriting to look at whether or not we're going to pay back. Then it needs to go to compliance to make sure that we're not terrorists. Then it needs to go to risk. Then it needs to bounce around many different departments. Each one of those departments has its own set of processes, needs the data in their own specific format to get it going. So what you're talking about by trying to retool this and insert a digital form, while that looks good on paper, unintended, in reality, what you're talking about is retooling a business process that is spread across multiple different parts of the bank and involves thousands of people in total. That's a huge undertaking for a bank to go through. It's more than just replacing the paper. It's fundamentally retooling the process to be quote unquote digital first in nature.
And that was the debt I was talking about. The debt is that process debt, that people debt, that learned behavior. And some of these fintechs can come in and go, we want to offer mortgages. We've got no operational debt of how we do it previously. We'll work out those processes and build them from the first time and structure it so that there isn't ever a piece of paper that's passed between risk and compliance and risk and auditing and credit check, and there won't be those process steps. Is that where that innovation and speed comes from these fintechs, because they've not got that operational debt?
It's one of the areas, and we'll hit on this, just kind of tipping our hat to next week here. You're really seeing innovation beyond just digitizing the paper. You're seeing innovation, we'll call it in 4 buckets. One, Stephen, is exactly that, what I would call going beyond the form and automating more of that business process around the digitized data, because now you've taken paper out of the equation. You've got that startup has the expertise. They know where they are embedded in the process. They're right at the start, and they can start adding on, say, hey, we can do the next 2 steps, the next 3 steps, the next 4 steps. So that's one area for innovation. Second area for innovation, taking that data and doing that data, the digitized paper, doing the data transformation that's needed to go plummet into compliance, underwriting, et cetera, and deliver exactly as they need it, as opposed to the copy and paste in spreadsheets. Included in that, Stephen, I would say, is the analytics. So basic things. If I take your bank statement, I can look at the credits and debits for a period and make sure that they add up to the total at the bottom. So you haven't tried to, say, fraudulently change how much money you moved around in that period. So basic analytics against the data. Third use case, take that data insights, especially the aggregated anonymized ones, and sell it to new companies. So good examples there. We can imagine if you've got a full picture of who somebody is, their finances, there's a lot of startups, wealth advisors and the like, for whom that would be very valuable data. You can compare urban versus suburban or what have you type use cases. The fourth one, and you hit on this, is beyond just digitizing the process, throw the whole thing out the window and start over with fully digital first forms and never touch a piece of paper. There are limitations to that, at least for the time being. Like our licenses, our passports are still quite physical. So there's almost certainly a use for that. But insofar as we can minimize, say, novel forms that we have to fill out and just start digital first, there's a couple of folks that are really starting to crack into that space. And that's exactly where we're going next week.
And I think that gives us a natural end. We try and keep the show to 30 minutes. I think we failed spectacularly on every episode if you've not listened to previous episodes, but we'll be slightly better today, I think. I think that gives us a natural break. I think next week we're going to be diving more deeply into this subject and talking about kind of where that innovation comes from. So thank you for today, Jared. My name's Stephen Dickens. You've been listening to myself and Jared Klee. We're from the Fat Tailed Thoughts podcast. If you like what you've heard today, please click and subscribe. If you've got any negative comments, Jared's Twitter ID is Kleebeard. If you've got really positive things to say about the show and what you've heard today, at Stephen Dickens 3. So we kind of bifurcate the sort of positive and negative comments here. But seriously, click and subscribe. Tell your friends about us. If you really like what you've seen, give us a 5-star rating. We'll be back next week with part 2 of this series. Thanks very much for listening, and we'll speak to you soon.